and Thies solution, Thies method of solution, using the well function table. Now, when we conduct the pumping test analysis is done to determine the Ackford constants, that is storage coefficient and transmissivity coefficient. So for this, if you look at the pumping test, will result in somebody has come. The if you look at S and R square by T, they are obtained from the pumping test. S is the drawdown, R is the radius of the observation well, and T is the time, and corresponding drawdown is S. So what you have will be, in fact, you will have a data something like this: time, and then water level. So these two you will have. So from these two, you can calculate the drawdown, right? Now, so the relationship between S and R square by T will be similar to the relationship between WU and U. So, if we make two plots, one plot R square by T versus S, and another plot U versus WU. So this second one, that is WU, this is a standard one, and it is called the type curve. So let us look at the data. See, this is the data. The pumping test is done in a sandy aquifer. The original water level is 20 meters above the mean sea level. See, this is the, so this is 20 meters. It is given as, H0 is given as 20 meters. Now, the discharge is Q. The discharge is Q. Then the observation well, this is the observation well. So it is located at a distance of 1000 meters from the pumping well. This is the pumping well. This is the pumping well, and this is the observation well. So the water level in the observation well is noted at different times. So 0. Initially, here the water level will be full, 20. Then after 3 minutes, it was noted that the water level is 19.92. So like that, the observations were taken up to 100 minutes. Up to 100 minutes. So these are the water levels. So from this, you can calculate the drawdown. So how do you get the drawdown? Drawdown is given by S is equal to H naught minus H. So that means 20 minus this. So like that, so this is how we'll get these values. So these values are obtained using this relation. So here H naught is equal to 20. That is what is given. So what we do is, so this is the time, this is T, and this is S. So this is a simple graph between drawdown and time. This is a normal graph. That means normal graph sheet. Now what we do is, we take a log sheet, double log, and this particular one is a standard type curve. So how do we get this? This is the one. See, these are the values of U. And these are the corresponding values of WU. So this graph is obtained from that. So this is a standard one available. So here we have used a double log. So here also what we do is, this is our observation data. So we have time, and what is R equal to? according to our problem, R is equal to 1000 meters. So R square by T. This is T. So this is R square by T is meter square per minute. So this first value will be 0. Sorry, the first value will not be there. Because T is 0, R square by 0 is infinity. So this will be the values. So if you look at this, R square by T value 10, this is 10, that is 10 to the power of 1, this is 10 to the power of 2, this is 10 to the power of 3, like that. So 4, 5, 6, this is 10 to the power of 6. Now we have this data straight away, S values straight away. So now we plot them. R square by T on x-axis, and S on y-axis. You can see, for example, it is 10 to the power of, here, this value, 10 to the power of 5. So for 10 to the power of 5, S value is 0.55. You can see here, this is 10 to the power of 5. So for 10 to the power of 5, this is the point. This is 0.1, 0.2, 0.3, 0.4, this is 0.5, and this is 0.6. This is 0.6. And this is 0.5. So this is 0.55. So that is how we have plotted. So we must prepare this plot. We must prepare this plot. And then join these two. How? See, this is the bottom one here. This is our well data curve. Well observation curve. So this is drawn between S and R square by T. So this is the same log graph. Now this one, the top one, this is your type curve. So what we have done is we have taken the our plot and we have some points like this, and then we had taken the type curve and we have shifted this type curve parallel to the axis, keeping both the axes parallel such that some part of the type curve matches with the observation data. You can see here. See, it is matching here. So, in that position, select any convenient point. That point need not be a point on your type curve or on your field data curve. Any point. You see, here, this point is taken conveniently. And note the corresponding values of S and R square by T. And also the corresponding values of U and W WU. So the match point coordinates are given here. WU is equal to 1 and U is equal to 0.1. Similarly, S is equal to 1. S is equal to 1 and R square by T is 2000. This is 1000 and this is 2000. So when once you get these four values, so use these four values in our definition. Our original equation is this one. T is equal to T is equal to 4, sorry, S is equal to okay. This one. T is equal to correct. T is equal to I have forgotten. T is equal to
Sir, what is the thesis method? Sir, briefly explain, sir.
what is
All option. This method is.
uh, this is Thies has given this procedure. So this is called as a Thies method. Thies method is done in two ways. One is directly using the well function table. But for that, you must know, that is used only when the ACFR characteristics are known. See, I have shown this method. See, this is the one. So when you know transmissivity and storage coefficient, then you can use the well function table to determine the drawdown at any location for any time. So this is one application of the Thies equation. Then actually this is only possible if S and T are known. But in general, S and T are not known. So this method is used, pump test analysis, this Thies method, to determine the constants T and S. So for that, what we do is we conduct a pumping test and generate this data. Generate this data. Now use this data and plot this graph.
Sir, it is a confined aquifer, no?
Yes, it is confined aquifer. It is only for confined aquifer. For unconfined aquifer, still we have not considered. This is unsteady state. Earlier one, what you have done was steady state. Do you see the difference? Do you understand the difference?
Yes, sir, following.
Okay. So, what we have done is, we have obtained a match point and we use this equation. T is equal to Q by 4 pi
Sir, WMB means match point, sir.
W.
Match.
See.
Match point at a well
match
condition.
point. See the match point. I will once again tell. See, have you understood this up to this?
No, sir.
This one?
No, sir.
Did you not understand this point?
No, sir, I not understand.
Okay. Have you followed this?
Yes, sir, drawdown I followed.
This is observed data. Okay?
Yes, sir.
So this is the data we have. Actually, we will have only up to this. And this is calculated by subtracting these values, each of these values from 20. 20 minus 20, 0. 20 minus 19.92, 0.08. 20 minus 19.85.
Sir, H1 minus H2.
Not H1 minus H naught. H naught minus H. H naught is standard 20, equilibrium value. See, this is H naught. See, this is H naught. This is H naught. Now, what happens when you start pumping? Initially, in this, the water level is here for some time. Next time, it will be here. Further time, like that, it goes on reducing in the observation well. This is the observation well. So, the data that is given here is, correspond to the observations in the well. So, at 0 time, the level is 20. After 3 minutes, the level is 19.92.
Yes, sir, followed, sir.
Right?
Yes, sir.
After 100 minutes, it is, say, for example, it is 17.5. Okay? So this point you have observed, followed.
Yes, sir. Come to next slide, sir.
Yeah, I am going. So next, this is not required. In fact, we need not draw this graph. This is only for your understanding. This graph is shown, right? Next, what you have to do is, you have to calculate R square by T. Now you are having the values of T and S. But we have to plot a graph between R square by T and S. So for every T, we calculate this. Is this clear?
Sir, what is R, sir?
R is the distance of the pump observation well from the pumping well.
Okay, sir. 1000 meter.
Right?
Yes, sir. 1000 meter.
Yeah. So 1000 into 1000, that is 10 to the power of 6. Divided by T. So the numerator is always 10 to the power of 6. The denominator is 0, 3, 4, 5, like that. Right? For example, if I take this 10, what is R square by T for this? 10 to the power of 6 divided by
Yes, sir. Followed, sir.
10. So it will be 10 to the power of 5. So 1, 2, 3, 4, 5. This is 10 to the power of 5. So like that, we have to calculate R square by T and enter the corresponding values of S. This you need not bother. This you need not bother. Just they are shown here. Now what you do is, you plot this on a log sheet. You plot this on a log sheet. Okay. Now what you do is, you got this. Now you take a standard type curve. So this is available. A standard type curve is available. Otherwise, you have to prepare for yourself and keep it for us. So, okay. Now, next thing is, bring both of them together. As I told, this is one graph, and this is another graph. Both of them keep such that the axes are parallel. And you shift the type curve left, right, or up and down, such that you obtain some
Point.
matching between the match type curve and your observation points. Right? Followed?
Yes, sir.
So, when once you get this matching, then you take any convenient point. That convenient point, as I told, it need not be on this graph. I have taken some convenient point, readability. See, if I take the intersection between two axes, it will be very convenient for me. See, this will be WU will be 1 and U is 0.1. I can take this point also. In that case, U will be, this is 0.1. So, I have to count. This is 0.1, 0.2, this is 0.2, this is 0.3. Huh? This is, I think, 0.4 or 0.5. This is, I think, 0.5. So, so this will be 0.5. And WU is 0.1. And corresponding value of S is 0.1. And R square by T will be this value.
100,000.
Huh? 1 minute.
100,000.
So this is R square by T. So we consider that values. Instead of this, we can take the other values also. So now T is equal to Q by 4 pi into W and S is equal to 4 T U divided by R squared by T. How do you get this? These are our original equations. This is our original equation. And this is our original definition. Now what I will do is I will copy these two and I will take them. See? Oh, sorry. So S is equal, small s is equal to Q by 4 pi T WU. And U is equal to this. So So here for WU, we will be using match point data. For this also, match point data. And match point data. And for R square by T, also we use match point. Understand? Have you
Yes, sir.
followed?
Yes, sir. Following.
Hmm. So automatically you will get T and S. So this is how we determine the Ackfer constants, that is S and T, with the help of the pumping test data. So for that, the procedure is first you have to conduct a pumping test and measure continuously at different times of instance the head in the well. Alternatively, you can also directly measure the drawdown. It doesn't matter. We ultimately want drawdown only. So, in fact, it is always easier to measure the drawdown only because you can use some device and find out the water level. So, that is how we generate the data. Then follow the procedure. Is it clear? I will proceed to the next one. Now, I want all of you to note this problem. All of you note this problem. It is in FPS units. So convert the data into MKS units, SI units. So gallons per minute is there. So convert it into meter cube per hour or meter cube per day, whatever convenient is possible. Better use meter cube per minute because here the time is in minutes. And drawdown you convert to meters. So when once you note this problem, I will proceed to the next method and you have to work out this problem and submit to me. So for that, what you have to do is the first point you have to do is prepare a
Drawdown करो.
no, first you have to type करो standard one. W on the y-axis and U on x-axis. So there are two methods for this. One, use the table and plot on a log. Second alternative is download and get a print. Whatever you do, the type curve should be available on a transparent sheet. అప్పుడే వచ్చారా మీరు? So to the extent possible, the sheet should be transparent. Why transparent?
Papers dull.
You have to
One bar.
match with your observation data curve. So you have to see. Otherwise, it is not possible. Okay. Then, of course, you draw the r square by t versus small s. Here, drawdown is directly given. So this is itself is yes. And this is t. And what is r? R is $2,000 feet.
200.
200, sorry. So 200 feet. So then, yeah, procedure. Once you prepare this, match them and get the coordinates, matching point coordinates. And the rest is simple. Right? So this is an exercise for you. Now, I have, in addition to this data, one more data. Now we will proceed to the next method. But before that, I would like to leave this sheet so that you note it down. I will come back within 5 minutes. Now let us proceed to Jacob method. So now are you ready for the next method?
Okay, sir.
Okay. So Jacob approximation. In Jacob approximation, again, there is no change in the equations. This equation is same and this is same. And what is done is, the well function, which is a series, is approximated by first two terms only. So the remaining terms are neglected. The only condition is small values. So when you use this, automatically you can rewrite this equation so we'll for WU I write point minus 0.5772 minus log U. And what is U? U is this. So now this is the natural log is converted, and this is also absorbed. Now how to do this? How to arrive this? Now this is again an exercise I am giving to you. All of you, take pen and paper and show that these two are one and the same. How do you proceed? Number 3,
Sir,
how do you proceed? If you want to prove equation 1 and equation 2, are same. So if you are asked to prove, how do you do? No idea?
no, sir.
Okay. Number 4. Harika. Are you there or left? Harika is not there. Number 5.
Sir.
Hmm.
Sir,
Can you
Harika,
prove?
the mic problem, sir.
Okay. It doesn't matter. Number 5.
Sir.
Can you
Didn't
prove?
get, sir, any idea.
How do you prove?
No, sir, not get any idea.
You don't know.
Yes, sir.
Number 9.
సార్ ఐ మీన్ లాగ్ టు ది ఈని లాగ్ 10 కి కన్వర్ట్ చేసినప్పుడు 2.3 అదే లాగ్ 2.303 బై లాగ్ ఎక్స్.
But there is a constant there.
సార్ అదే ఆలోచిస్తున్నా సార్. మామూలుగా కన్వర్జేషన్ లాగ్ ఈ నుంచి లాగ్ 10 కి చేసినప్పుడు 2.3 అవుతుంది సార్. అక్కడ కన్ఫ్యూజ్ అవుతుంది.
So think, ఆలోచించవచ్చు.
ఓకే సార్.
Number 12.
Sir.
How about you?
I don't understand, sir.
You don't know. 13.
Yes,
13. Is 13 absent or what? 14.
సార్
How do you do?
అంటే మనం ఎల్ఎన్ ని లాగ్ 10 లో కన్వర్ట్ చేసినప్పుడు అది కాన్స్టెంట్ వాల్యూ క్యాన్సిల్ అవుద్ది కదా సార్?
ఎలా క్యాన్సిల్
I
అవుతుంది?
mean-
కాన్స్టెంట్ వాల్యూని ఏం చేస్తావు?
అంటే దాన్ని డబ్ల్యూ ఆఫ్ యూ అని అన్నారు కదా. మామూలుగా డబ్ల్యూ ఆఫ్ యూ 0.5772 కదా సార్.
అవును.
యూ అనేది 0.01 కంటే నార్మల్ గా ఉన్నప్పుడు దాన్ని తీసేసుకోవడానికి కుదురుతా సార్?
No, no. See, your equation, you forget about all other things. Now you are having a problem, equation 1 and equation 2. Now you are supposed to show equation 1 and equation 2 are same. What do you do?
నథింగ్, ఐ డిడ్ంట్ సార్.
ఆలోచించు. 13. తనుజ. What happened, Tanuja?
తనుజ ఆబ్సెంట్ సార్.
తనుజ ఆబ్సెంట్. ఓకే. ఇందాక వచ్చింది.
మేబీ నెట్వర్క్ ప్రాబ్లం సార్.
Oh, maybe. Okay. Next. See, it is very simple. What you have to do is, you have to convert that minus 0.5772 also as a something to the log something. So if you write log x is equal to minus 0.5772, what is x? ln of x, all of you note it, ln of x is equal to 0.5772. So, what is x? What is the definition? Natural log.
e పవర్
Log of
0.577.
So e power 0.5772 is x. ఎంత చూడండి, క్యాల్కులేటర్లో చూడండి, e ద్వారా 0.5772 ఎంతో. మైనస్ చూడాలి. e to the power of minus 0.5772. It will be log something.
Here is the answer.
$2.25.
$1.781.
ఎంత?
1.781.
1.781. 0.278. 1 point రాదే. ఎంత వస్తుందంటే 1 minute. టూ 2.25 into 4 వస్తుంది.
0.561.
నైన్ రావాలే. నైన్ రావాలి.
0.5614 వస్తుంది.
పాయింట్ 56. అంతే కరెక్ట్. 0.56 కరెక్ట్.
Yes, sir. 0.56.
So what we do is, I will show you. So this is written as (5772) is equal to దీని బదులు ఏంటి రాయొచ్చు అంటే దిస్ ఈజ్ లాగ్ జీరో పాయింట్ 56 minus log u. Right? So now how can you write this? This is log zero point 56 divided by u. So this is written as log 0.56 u అంటే ఏంటి మనకి r squared s by 4tt. So 4t T will go to numerator and R squared S will come to the denominator. So this is log 2.25 approximately. Adi T divided by R square S. So this can be written as 2.3 log to the base 10. Right? Followed? అర్థమైందా?
Yes, sir. That.
So this is how we write that. Now our procedure is this. So now have this equation. So now you draw the graph directly between and T. S ordinary, this is semi-log graph. Because S is normal and T is your logarithm. So you have to draw a graph between log T and S. Okay. Now, after drawing this graph, these are all your points. And you draw a tangent and see, extend it up to S is equal to 0 point. S is equal to 0 point. So 0 is equal to 2.3 Q divided by 4 pi T log something. So when this will be 0? This will be 0 when this quantity is equal to 1. What is log 1 to the base 10? Log 1 to the base 10 is 0. So this value will be T naught. So S is equal to 2.25 T naught by R square. Now, the work is not over because still your T value is not known. If you want to calculate S, capital S, that is storage coefficient, from this equation, value of t must be known. So what you do is, the next step, you go back to your sheet and then you select one cycle. This is 10 to the power of 2. And this is 10 to the power of 3. This is one log cycle. So you call this as T1 and this as T2 and this as S1 and this as S2. So what is the difference between S2 and S1? It is delta S. So use your equation. Our original equation is this. S is equal to 2.3 Q divided by 4 pi T log this. So, same thing. So, I'll write that. 1 minute. I'll close it and so what I will do is, I'll write S2 is equal to similarly S1 is equal to, so I have two equations. So find out what is S2 minus S1. S2 minus S1 will be this minus into this is 1. So it will be simply 2.3 Q by 4 pi T log T2 minus 1 only, because this is a constant value. When you are dividing, see log, 1 minute, log, I can write this as log something constant and then minus log so when I am subtracting this minus this, it will be log so therefore you will get this equation. S2 minus S1 is nothing but delta S. So after this, This is used only to get the value of T naught. So, now you substitute delta S here, and Q is known, T1 is 1. Log T2 by T1 is 1. Log T2 by T1 is 1 because it is one cycle apart. So, delta S is equal to this. So, you know this, you know this. Hence, you calculate T. When once you calculate T, use this equation and substitute values of T, T naught and R square. So you will get yes. Is the procedure clear? Okay. So these are the calculations. So here T naught is 8. This is 10, so this is then S2 is 5. And S1 is 2.6. So delta S is the difference between these two and is 2.4. So use this value. T is equal to Q is how much? Okay, I have forgotten to. Okay, I have forgotten to give that data. Okay, anyhow. So Q is 1000 meter cube per second, per hour. I think it is only the same problem, a clear problem only. 1 minute. I will see back. I will go and see back. Same data. Q is equal to 1000 meter cube per hour. R is equal to 1000 meters. So Q is equal to 1000 and R is equal to 1000. Right? Have you followed? Is Jacob method clear to you?
Okay, sir.
Any doubts? Now, I have given this problem. So you solve this problem also using Jacob method. For this, you don't require a type. Straight away you can do it. So, in the university examinations, this can be given. Only what you have to do is, you have to ask for a semi-log graph and fit in your data. Enter your data and draw the line, extend it 0, s is equal to 0. And then note this delta s corresponding to 1 log cycle difference. Okay, so you can expect a university examination question on this. Okay. The next one is your recovery method. So I think we'll stop here, and recovery test method we'll consider tomorrow. Tomorrow, tomorrow whole day, I think you're free. So suggest tomorrow